Hey everyone, good day to all of you. Good morning, good afternoon, good evening, wherever you are. Thank you for joining to the pre-conference webinar we're having today. But before jumping into the actual talk, I just want to give you some context on why we're doing these webinars. It's because in just 20 days, we're going to have the Selenium and Appium conference here in Valencia between the 26th and the 28th of March. We're going to have this conference, and we have a wide range of topics that are very rich, very diverse, and for the first time, we're having topics that we didn't have in previous conference. For example, we didn't cover much things about video game automation, accessibility, which is a huge topic this year in the European Union, obviously AI in testing, observability, which is use case for WebDriver and automation in general that is growing and growing in this industry, and of course the WebDriver ecosystem. We have a great agenda, a great set of talks, and this is mostly thanks to this great group of people who created this agenda. So thanks to them, the review committee, the organizers, we're very thankful to them because thanks to them, we have this agenda. You can go and check the agenda already in seleniumconf.com/agenda. You will see that we have great people like Angie Jones, we have Almudena Vivanco from Spain, we have different type of talks from people from all over the world. And this set of talks, it was possible to have them just because there was a large amount of submissions sent to the conference. We had over 200 submissions, and unfortunately, we don't have slots for everyone. So that's why we're doing this pre-conference webinar, to give the space to some of the great submissions we had, give them the opportunity to share their knowledge, their insights, the different learnings in their automation journey, and that's why we're doing this. Before jumping to the talk we have today, a quick reminder that you can still register for the conference in seleniumconf.com/register. If you use this discount code, the pre-conf webinar, you will get a 10% off your conference ticket. Today, we have a very interesting talk from Attila. This was one of the talks that was one of the proposals as well that was interesting to me because, to be honest, as one of the leads from the Selenium project, we don't see many GitHub issues or many people requesting examples or having issues with Kotlin. So this was also like opening my eyes a bit to see what's going on with different aspects that people do with Kotlin. So that's why we have Attila today here. So Attila, thank you for being here. Welcome to this webinar. I really appreciate that you have the time and the availability to share your knowledge and content with us. I forgot to introduce myself. I'm Diego Molina, one of the leads at the Selenium project and also the conference chair. So if you want to introduce yourself, Attila, as well, please go ahead.
Sure. I'm Attila, and I am a test automation engineer, currently working in the medtech industry. On our backend team, where I write test automation in Kotlin.
Great. I think that was it from me. I just want to thank you again to everyone who is here joining us, and also obviously to you, Attila, for your time and for your willingness to share knowledge with the community. I'm going to stop sharing my screen so you can share yours. Please share it whenever you can, and then I will leave you so you can take the stage all for you. All right, here's your screen.
All right.
There you go.
All right.
Okay.
Hello, everyone.
Thank you.
Yes. Hello, everyone. First of all, I would like to thank you for inviting me. It's a pleasure to be here and to meet the community. As I said, I'm Attila, and I am a test automation engineer with over 50 years of experience. I started to explore Kotlin about 3 years ago with the motivation to find out better abstractions to express Selenium test in a compact way. And while I was on a quest to find out what could be done when combining Kotlin language features and tools, I discovered a nice alternative to the page factory class, and as well as Kotlin's domain-specific language capabilities. Together, we will explore the results of my experimentations, and we will craft Selenium tests that are maintainable, expressive, and easy to comprehend. First, we will discuss why Kotlin is an excellent choice for Selenium test automation. Then I will showcase some language features and concepts that are relevant to this talk. After that, we will discuss the page object model pattern and its implementation in Java through the page factory class and its limitations. Following that, I will showcase a unique approach to solve these limitations using Kotlin's powerful feature called delegation. And finally, we will touch on the domain-specific language functions. These functions use syntax aligned with the problem domain, making them self-explanatory and very intuitive. We will take baby steps, introducing one concept at a time. And as the session progresses, we will continuously refine our code by leveraging Kotlin language features and best practices. We will write idiomatic Kotlin code. That is how a native, quote-unquote, a native Kotlin speaker writes code, leveraging syntactic sugar and language feature where appropriate. So there is a lot to unpack. So without further delay, let's get started. So Kotlin is a versatile, pragmatic, general-purpose programming language. It can be used for a wide range of applications, including backend development, front-end development, mobile testing, mobile app development, as well as testing. By combining the best of object-oriented and functional programming, Kotlin enables us to write expressive, concise, and maintainable code. Based on my experience, the biggest challenge with test automation is maintenance. Kotlin addresses this issue by reducing boilerplate code, and it truly shines in its conciseness and expressiveness, bringing clarity and simplicity to your Selenium tests. It's fully interoperable with Java, allowing you to gradually introduce Kotlin in your existing Java code. Additionally, Kotlin takes inspiration from other languages, for example, JavaScript, Python, Scala, C#, incorporating modern language features and better tested concepts to enhance developer productivity. So let's switch to the IDE now, where I prepared a monorepo with submodules. I use Gradle as a dependency manager and build tool. I write my page objects and util functions in the main source set and keep my test in the test source set. So let's start with the top-level functions. Top-level functions in Kotlin are defined outside of any class, allowing them to be called without needing an instance of a class. So unlike in Java, where you must place functions or methods in classes, in Kotlin you don't need to create those meaningless classes. Instead, you can define functions outside of any class in the source file. These top-level functions are compiled to static methods and can be called as regular functions. In fact, main is also a top-level function. Single expression function, as the name suggests, it's a function that consists of just a single expression. So I can remove the return type, the curly braces, and the return statement if there is one, and place the single expression after the equal sign. I can do the same with the say hello function. Please notice the unit return type. That's Kotlin's equivalent to Java's void. Extension functions are defined as a member of a class but or can be called as a member of a class, but they defined outside of it. So in this example, I have a function that is called open defined on the WebDriver. So even though I don't have access to the WebDriver interface, I still can extend it. All I need to do is prefix the function with the class or interface name. Then I can have access to the WebDriver members and properties. So I can call any functions that is available there. And similarly to top-level functions, extension functions can be called as regular functions. This is a typical Chrome driver setup. Notice that we are repeating the driver name during this configuration. Luckily, we can eliminate this repetition with the help of scope functions. For example, we can use the with scope functions. This code can be read as, with this driver object, execute the following. The return time of with is the last expression in this code block, and use with when you want to perform multiple operations on the same object and you don't want to use the return result. But since we, as you can see, we are returning with the driver in the last expression, there is a more idiomatic way to achieve the same result using the apply function. So the apply function is similar to with, but it returns with the object as well. So this code can be read as apply the following assignments to this Chrome driver object. Use apply when initializing and configuring objects. So after discussing top-level extension and scope functions, let's now move on to the page object model design pattern. The core idea behind the page object model is to separate the interaction logic from the actual tests and reduce maintenance and enable reusability by encapsulating and centralizing UI element and providing public APIs to interact with the page. Overall, it's a nice solution for organizing code with some useful abstractions. Selenium offers support implementing the page object model in Java through the Page Factory class. Originally, it wasn't intended as an official implementation. It was more like an example of how page object could be implemented in Java. Nevertheless, I have my fair share of doing page object with Page Factory because it's convenient. It's great because it reduces a lot of boilerplate code. However, as its creator, Simon Stewart, noted, its implementation is suboptimal and making it available to the public wasn't the best idea. It's not actively maintained in Java anymore, and it's already been removed from the C# binding. So why the implementation is suboptimal and what are the limitations? First of all, when Page Factory init element called, it scans the current class for fields that are annotated with @findby and create proxy elements for them. So these proxy elements are lazily loaded, meaning the actual element lookup is not performed in the DOM until there is a interaction with the element, like a click happens. The problem occurs when one of these elements becomes stale and you handle the stale element reference exception by reinitializing the element using Page Factory init elements. And since Page Factory doesn't track which element has become stale, it will reset all the elements in the class, and this can lead overhead, especially if you have a lot of elements defined. Additionally, the Page Factory relies on annotations, and then that adds its own series of issues. For example, we cannot define synchronization code in annotations. The synchronization code must be placed in functions before accessing the elements. Furthermore, annotation needs to be compile time constants. So that means we cannot pass dynamic element locators or create them, or pass custom logic or conditions during runtime. And there is no way to use explicit weights with annotations. So considering these factors, it's advised not to use page factory with Selenium test in Java. So let's not spend more time on page factory. Instead, let's dive into the property delegation. Kotlin provides first-class support for delegation. But what is delegation? Delegation is a design pattern, a way for an object to delegate its responsibilities to another object. And delegation in Kotlin is a pragmatic, modern approach for code organization and reuse. In Kotlin, we can delegate classes and properties. However, class delegation isn't particularly relevant for us here, so let's talk about property delegation. In property delegation, the functionality of the property is encapsulated and outsourced to another independent reusable helper object known as the delegate. And this is done using the by keyword. So if we inspect the inventory page classed in this basic POM test, and is this title text function, notice that each function call will issue a new find element command. To demonstrate this, I will duplicate this line a couple of times and run the test with logging enabled. By the way, I'm using the Selenium logger. The Selenium logger library developed by Titus. It's very useful for understanding what driver commands are being issued while running Selenium tests. So let's inspect the logs. As you can see, there is an extra find element call before each get element text. That is because we are not caching the result from the first call in the subsequent get element text call. So let's address that with our first delegate, the lazy delegate. The purpose of the lazy delegate is to initialize the property when it's first accessed and use the cached value for subsequent accesses. So again, to enable the delegation functionality of the property, we are using the by notation, and all we have to do is to write driver find element by class name title in a lazy delegate. That's it. We have implemented our first delegate, and let's test it. So again, I have the title text call 3 times. And if we inspect the logs, we can see there is no more find element call in between get element text calls anymore. So this lazy delegate improves efficiency by reducing unnecessary driver commands. So let's see what else we can do with delegation. For example, we can write a custom delegate to find elements. In this example, name is an extension function on the WebDriver that takes a value string. This value parameter is the attribute value for the name locator strategy, and the function returns with a read-only property. So what exactly read-only property? Read-only property is an interface in Kotlin that represents a read-only property delegate. And it is used for the val properties. Those are the immutable properties. And it customizes, it's provide a way to customize how the property value is retrieved when it's accessed. So essentially, what we are doing here, we are implementing the read-only property with a lambda expression where we find the element and return it. The underscore means we don't intend to use the parameter. And we can test this as well. And if you are wondering why my test is slow and why I have this red square around elements, because I'm decorating the driver with a slow motion decorator and a highlighter decorator, just for demonstration purposes. So how about using delegation for synchronizing elements? I'm going to demonstrate this feature with this delayed enable button, where the button appears after a slight delay. Let's find the corresponding test and let's run it. As you can see, the test failed with element not interactable exception. This is because even though the element is in the DOM, but it's not ready for interaction. So let's address that. So what I want to do is to define the synchronization condition next to the element definition. So essentially, I want to break away from the traditional approach where we place the synchronization code in functions before accessing the elements. So what I want to do is to open up the braces here and wait until this button is displayed. I'm going to cheat a little bit by inserting the updated implementation of the ID function. This is a lot to take in. Let's break it down. So again, ID is an extension function on WebDriver that takes a ready condition as well this time, where the ready condition defined as an extension lambda on web element that takes no argument and returns with a boolean. Don't worry about it. We will come back to this code once we discuss DSS. In the function body, I'm first creating a fluent wait, then I keep querying the DOM until the element is ready. Once the ready condition evaluates it true, I know that the element is ready. So then I can call the find element function one more time to return with the element. The code doesn't compile it because I haven't defined the synchronization strategy for the message property. But I can address that with Kotlin's default parameters, where I can set it to true. So that means consider message ready regardless of its state. So if I run this task now, as you can see, it worked as expected. I'm going to show you one more synchronization example, but this time I'm not going to implement the delegation by myself. Instead, I will import from my library Collibrium. So the page that we are automating is this images HTML, where there are 9 images popping up with some slight delay. And we just perform with some basic verification. Let's run the test to see what happens when we cache elements. As you can see, the test failed with timeout exception. And if we inspect the logs, we can see that the find element command was issued only once. It found one element, but it stopped searching. This is because Collibrium by default caches element using the lazy delegate. To address this, all we have to do is to disable caching by setting the cache lookup to false. Notice that I'm also overriding the default wait configuration with a faster pooling interval and a shorter timeout. And if I run the test one more time, it passes, and if we inspect the logs, we can see that the WebDriver issued find elements until the list of the elements, the size of the list has become 9, the synchronization condition that we have defined here. How about finding element using dynamic locators? I'm going to demonstrate this feature with Browser Stack e-commerce demo website. So if we inspect the page, we can see that these items can be identified by an index. So I can create an enum class for the products where I encapsulate the display name and indexes. And in the test, I can just iterate through these products and call the add to cart function, where I use Kotlin's string interpolation feature to inject the product index into the CSS selector string. And once I find the root element, I can create an item that represents an inventory item on the page. This inventory item encapsulates a root element. This is where the search starts from. And with the index of property, I can use Kotlin string interpolation feature one more time to find elements under the root element. This is as easy as it gets. So as usual, let's run the test to see it in action. Great. So far, we have seen how to find element efficiently, caching the result. Also, we have defined custom weighting strategy. We have seen how to use dynamic element locators. But how about handling the dreaded stale element reference exception? Collibrium by default will relocate stale elements when they occur, but only the stale elements will be relocated. To demonstrate this, I'm going to use this tail button HTML, where there is a button, but after 2 seconds, I remove this button from the DOM and replace with an identical button that looks exactly the same. It's placed exactly the same location and it has the same ID. However, when we attempt to click on the new button, a stale element reference exception will be thrown because the original button is not attached to the DOM anymore. And even though we have a new button in the same position, the same ID, it's going to result in a stale element reference exception. So let's run the test, and then we can inspect the logs. As you can see, there is a log entry stating that the button became stale and Collibrium relocated it. All right. If we inspect the login page, we can see that this driver, WebDriver, property is essentially a dependency on this login page. And to be able to call functions from WebDriver, I need to repeat this driver property name every time. I find this code a bit noisy, so I would like to get rid of this repetition. And I can achieve that using Kotlin's context retrievers. All I need to do is to place context WebDriver on top of the class. Then I can remove the constructor, and I then no need to prefix the functions. Let's see the concrete implementation. So as I said, we just need to place context WebDriver on top of the class, and now I can just call ID without prefixing the function. Before wrapping up delegation, I will show you how you can boost productivity in Aqua with page object templates. So let's assume we have implemented the property delegate for singular and multiple elements, and we want to start using them. And this is actually what I did in my library. So I'm going to create a Selenium page object. And this time, let's use this website. So I'm going to create a Selenium page object with a custom framework. And I have defined the templates in settings. So once I have the page, I can start using the built-in inspector. So let's create a username field in our code. Then password, let's pick another locator strategy this time, for example, data attribute. Then for login, let's use name. And this is enabled through Aqua's page object templates that you can configure in settings. So essentially, locating elements has been externalized and delegated to something else that we can reuse across multiple properties and across multiple page objects. There are no annotations, and we are not using the page factory class or the expected condition class, yet we have fully functioning page objects. Elements are lazily loaded and cached by default. The synchronization code is defined next to the element definition instead of placing the synchronization code to separate functions before accessing the elements. We can locate elements dynamically using Kotlin's string interpolation feature, and we are not relying on implicit waits anywhere in the code. Instead, we have full control over how long we want to wait. And Collibrium also relocates elements when a stale element exception occurs. So essentially, we have solved all the page factory pain points by leveraging Kotlin's powerful feature, delegation. After discussing delegation, now let's dive into the domain-specific languages. Domain-specific languages are specialized languages, programming languages for a custom industry and specific task. They offer tailored syntax and features to solve problems in a particular domain. For example, we can use SQL for database queries, HTML for web development, or Markdown for document formatting. And in Kotlin, we can develop intuitive, easy-to-read DSL-style APIs to address some specific problems. And these DSL functions improve productivity and promote reusability and enhance code readability. Let's switch to the IDE again and continue where we have left off. So this time, the login function returns with an inventory page to model the user journey through the application. And in the test, I want to be a little bit more expressive. What I want to do is to create a login page function, and inside the function I want to call login. And let's see the concrete implementation. As you can see, this login page function takes a block parameter that is defined as an extension lambda or lambda with receiver on the login page that takes no arguments and returns with unit. So this is actually a block of code that is attached to the login page, and this will allow us to access the login page properties and functions on the core side. So that means I can have access to the login functions inside this login page block. And this is great because it allows you to interact with the page in a DSS style. Inside the function, I'm creating a new login page where I apply the block of code. And since login page uses context receiver, I need to bring in the context using the with scope function. Now I want to continue working in an inventory page block. So the login page, as I said, returns in an inventory page, but now I want to continue in the inventory page, and I can do that with the help of invoke function that is annotate or prefix with the operator keyword. And again, this takes an extension lambda that is defined on the inventory page. And in the function body, I just call a block. And this allows me to again interact with the page in a DSS style. If we circle back to our synchronization example, where we define this ID function, notice that the ready condition is also an extension lambda on web element that takes no argument and returns in Boolean. And this enables us to define the synchronization code, and we also have access to the web element properties. So for example, I can call is selected enabled or write any custom condition to synchronize elements. Now I want to work on the pages as well, on the page objects. The send case function sounds like a low-level API, and indeed it is. I want to express typing that is more fluent and closer how we humans speak. So I want to write something like this: type, and this in this type block I want to write username into username input, and in the end I want to click on login button like this. Let's see the concrete implementation. So type again takes an extension lambda on the type scope class, and into is defined on the string type as an extension function again that takes a web element, and inside the in the function body we call the send keys command to type in the string. This infix notation is new. We haven't seen this before. By making the function infix, we can drop the dot and the parentheses, making the code more fluent. The click is defined as an object, which is a class without a constructor, essentially a singleton. And on takes a web element, and inside in the function body, we just click on the element, and again, we are using the infix notation to make the code more fluent. Let's run this test and see if this actually works. Great. I'm going to show you one more example. So this time the inventory page can take a bypassed login Boolean parameter that defaults a true. So when automating the UI, if we perform login before each test, it slows down the execution. Only dedicated login test cases should test the login functionality. The rest of the test should inject a cookie with credentials into the browser to bypass the login. So if we inspect the inventory page, we have init block that is executed during class initialization. And in this init block, I add the cookie to the WebDriver as long as the bypass login is set to true, and also navigate the inventory page. And this is another great example of DSS. Under the hood, the add cookie function takes care of adding the cookie to the driver's option. Let's run this test as well. And as you've seen, we bypassed the login. To wrap up DSS, I will show you the last example. This time, I'm not extending from a base test. Instead, I have defined the Chrome driver in the actual test. I think this Chrome driver definition has a nice structure, and it's self-explanatory. And it's another great example of DSS. As usual, I'm decorating the driver with slow motion decorator and highlighter. And the test looks exactly the same, but this time I'm using this DSS type products page, and the product enum doesn't store the index anymore. Instead, in the add to cart function, we call a find product ID function that is using this product property that is delegated with the lazy delegate. And inside this product lazy delegate, we call get products, where we send the get request to this endpoint to fetch the product. And you can see the product data class defined here. And once we have the products, we can find the first element where the product description equals to the product enum display name, and then we just take the ID. And we can use that ID with Kotlin string interpolation to create this CSS selector and find the root element. And the rest of the test is same as before. I'm going to run this test, and then we will inspect the logs. As you can see, there is the request to the endpoint, and here is the response. There is the ID, and this call was executed only once, even though I have defined two enums and iterated through them. Notice this add frontend DSA. This is marker DSA. The purpose of this DSA marker annotation is twofold. First of all, it helps with promoting functions and properties on the top of this list because the IDE is aware of what functions and properties are available in the given scope. And also, if I make a mistake during configuration, for example, if I place an options block inside the argument, it will not compile because it's aware of how these DSLs are constructed. Secondly, we can set different styles for syntax highlighting. And the ID with these annotations, there is one for the backend as well, by the way. So the idea is to, if you are working on a full stack application, you can create your functions in different packages for front-end and backend, and then you can annotate the public APIs with this backend API and front-end API annotations. Then it will be visually clear where you are using these APIs in your test and page objects. So when designing DSLs, start with the use side, design how you imagine the APIs being used. All you need to remember is the extension lambda. This is the most important language feature when designing DSL style APIs in Kotlin. As we saw, Kotlin really shines by bringing clarity and simplicity to the test and the underlying page objects. At first glance, it looks like magic, I get that. But once you start breaking down the concepts and understanding Kotlin philosophy and getting used to the syntactic sugar, things become clearer and it's all start to make sense. We have seen Kotlin property delegation for a streamlined element, synchronization, and we use boilerplate and also defined intuitive DSL style APIs to improve code readability and maintainability. What we have seen, it also applies to other JVM testing libraries. For example, you can easily write delegate functions for Appium to locate mobile elements or cache API calls in your backend testing frameworks. Collibrium comes with some cool features such as code generation, JUnit integration, various configuration options. And please go check it out. You can find me online with my handle, Attila Fazekas. And if you have any questions about working with Selenium and Kotlin, please reach out to me on LinkedIn. I would be happy to share more ideas about applying Kotlin features to Selenium tests that couldn't fit into this webinar. I hope this session provided you with some fresh ideas and practical takeaways. And having said that, thank you for the opportunity. Diego, over to you.
Thank you. That was very insightful. That was very detailed. Yeah, I don't use Kotlin often, but I do like how easy the language looks in the sense of that you can read and understand what is happening easier than Java. Because Java is more verbose and all that. So that's quite nice. Aside of Android apps, I don't know, because my impression is that Kotlin is not so popular in the automation world. So what is your impression there?
Yeah, I have the same impression. I think it's not picked up by the testing communities yet, but it certainly has its potential.
Yeah, my assumption is that Java has so much documentation and so many examples online that people tend to start with that. But yeah, ideally, people could start with something that is more simple, like Kotlin, or even more simple structures like Python, things like that. But people, I feel that end up with Java and Selenium and other tools just because that's what they see more often online, and not because they evaluate what language could fit better for them. Um, I'm gonna wait and see if there are questions from the audience. We had like around 20 people watching online, so I'm wondering if some of you have any questions. Please drop a question in the comments, and then we can take it. One of the things I wanted to ask before giving space to the audience was, um, so what was your motivation first to, create this framework, and then what made you think, okay, I will open source it and like put it out there?
So I was always interested in Kotlin, and I somehow like the syntax, and that draws me into this exploratory phase where I started to experiment. And I wanted to express Selenium test in a nice way, and I wanted to solve page factory limitations as well. Then I encountered DSR capabilities, and then also the code generation capabilities, and essentially the library started as a playground for exploring Kotlin language features and the tooling to write Selenium test in a very expressive way. And I tried a lot of things, and I'm still exploring it.
What was your? I mean, did you have to go through any compliance issues or something to publish the framework as open source?
There was a bit of challenge in the beginning, but then I found some guides that sorted out these challenges. Then recently there was a slight change in authentication for the Sonatype platform, but other than that, I think it's very straightforward, and you can use tooling to facilitate publishing packages to any platform, not only to just the Maven Central, but you can announce the release on GitHub, LinkedIn, or wherever you want.
Yeah, I am leaving there as a small banner the link for the framework, so other folks can have a look, and the people who are watching the recording also can check it out. Because I understand. So we have been discussing this in the Selenium team, how to make Selenium more simple, and our first approach is to leverage all the different frameworks that we have in the WebDriver ecosystem. However, one of the things that people are commenting us is that sometimes each framework works very differently, and then they need more guidance. They need like find ways to actually trust a framework because they have been using Selenium for a while, and then getting into a new tool also is a bit of a challenge. So what advice would you give to users that are looking for a framework that they could like open themselves to use something like Colibrium, or if they're using Selenite in Java, or maybe Selenium base in Python and so on. So how could you motivate users to jump into these frameworks? Because we're trying to do that in the Selenium team.
Mm-hmm. But if you talk about Colibrium, I think the pitch would be, if you are tired with the verbosity of Java, and if you are having challenges with page factory, then this library might be a good fit for you. And also, it helps you to reduce boilerplate because it has some code generation features, and it can be integrated with JUnit 5 seamlessly, and has a lot of configuration options. And you can find a get started guide on the website, as well as tutorials on how to start working with the Selenium module. The JUnit, the KSP, that is the code generation part, and the DSL module documentation yet to be written, but that will be the next step in the coming weeks. And I also plan to publish some blogs how to start using this library and Kotlin in general, how to approach test automation using Kotlin's features and syntactic sugar.
Sure. So just to extend the invitation to you, if you want to write a blog post, you can also use the Selenium blog, and we will be happy to host the content and promote your framework, and also share it in the social media, different social media platforms that Selenium has. I'm still looking, and I think either people are very confused or everything is clear for them, but I don't see any questions. I think the takeaway for me is that there is a lot of potential by extending different things of Selenium, and that's what we as Selenium developers have always wanted, that people understand the structure of the project and therefore then take advantage to shape it in the way they want, so they can use it as it fits best for their use case. However, this is challenging because you also need to understand how to do proper coding, different structures, and so on. But yeah, I think you are a great example of what the Selenium developers always wanted, to have someone that extends and makes the code work in the way they want. So yeah, we're on the top of the hour, and we didn't get questions, but if you are watching this video and you have questions and you want to reach out to Attila, you can just write a comment in the LinkedIn event, and then we will be watching that, and we will continue the conversation over there, so you can continue and engage with Attila and the framework that was created for Kotlin. Okay, so let's start to wrap up. Thank you, Attila, for being here. I really appreciate you had the time to share your framework with us and show us the different things you're doing in Kotlin. So thank you for that.
Thank you too.
Cool. I'm gonna quickly share my screen again, and then I just want to. Yeah, so today's webinar was with Attila, and please stay in the background, Attila. We'll have a little conversation afterwards to thank you again. But yeah, I just wanted to announce that in 1 week, we also have the next pre-conference webinar. So we're going to have Deepti, who is going to talk about privacy and so basically privacy, who is who, which is a super interesting topic with the GDPR changes happening this year in the European Union. They work at Paramount, so this massive platform for streaming, and they are taking care of privacy and data and all these things in a very serious issue. So it will be a very interesting setup to understand how a platform this size is adapting to the changes that are coming into the next European law in June this year. So you're all welcome to join. Remember that we have a conference in the next 3 weeks, happening in 3 weeks here in Valencia, and head to seleniumconf.com. You can have all the information over there. And I just want to thank you for your presence, for being here. And if you have any questions, any suggestions, any good feedback, either good or bad, like whatever you want to tell us, we are there for you at organizers@seleniumconf.org. Thank you for being here. Have a good evening, good afternoon, or good morning, wherever you are.